Hey, structured team. Today I'm going to show you how to code up and build your circuit for the structure portion of your project. We'll use this here in a moment, but for now, I'm going to show you how to build this thing with Tinkercad, which is just a way for me to show you how to do this real quick. You're going to need, in addition to your Arduino and a breadboard, you're going to need the distance sensor. Looks like this. Looks like little eyeballs, Wally eyeballs, an LED of whatever color you want, a speaker, and a push button switch. Um, all of these need to get wired up, and they typically are going to get wired up onto your breadboard. Right here, um, ground is going to go from the Arduino to this side here. This is called a bus. It allows you to tie into the ground from here whenever you want. And you're also going to need the 5 volts here. I'm going to go from here right to there. Why not? You could do it to either side, both sides, your choice. I'm going to leave these parts off of the breadboard, though you should probably put them on. It'll make things a whole lot easier when 'cause it'll keep everything in place. Your distance sensor, however, will need to be facing the ground, but also be at least 5 centimeters above the ground, the eyeballs, that is. Uh, use that information as you wish. So we need to tie in some of these things. The button is going to use just the ground right here to go from here to one of the pins all the way over here, pin 2, right there. Cool. So now we have a button. The LED, which will do orange, needs to go from pin 4. This is going to get real messy here, real fast. Over to the cathode. This would be the longer of the two, I believe. If it doesn't work, you always switch it around. Then it needs ground as well on the other side, like that. The speaker, which will make yellow, why not, is going to go from pin 5 and go all the way over here. Make it look cool. To the positive end, and then, of course, from the negative end to the ground, like that. Now, if you plug these into this breadboard, you're not going to have this insane mess of wires, just some mess of wires. Finally, we have our um, distance sensor right here. Distance sensor, if you zoom in here, it will say there's ground, 5 volts, echo, and trig. In fact, this is probably the wrong one. I'm going to make that go away. Where are they? Basic components, all of them. Here we go. I need the one with 4. There we go. VCC is positive voltage. Then there's trig, echo, and ground. Two of these should be somewhat obvious. The ground should go right there. So now it's grounded. The VCC is going to be positive voltage, which will go right over here to that one. The other two, which will color pink, the trig is the trigger. It's going to go to pin number 6 right there. And then we'll do gray for the last one. Echo is going to go to pin 7. Again, should probably be plugged into the breadboard. And if it's plugged into the breadboard, should not go in one line like this. It should go along lines this direction. and pointed at least 5 centimeters from the ground. Now we're going to go over to the Arduino IDE. We are structure team. And there's a few things we need to do off the bat. The first thing is we need to include a library that you can download off of Blend. Once you download it, it is a .zip file. You're going to keep it in a .zip. You're not going to extract it. You're going to go to Sketch, Include Library, Add .zip library. You're going to go over to your Downloads folder, find it, which is right here, and then open it up right there. It's gonna do some stuff right here, nothing crazy. And then you have to actually put it in your script. And you do that with the hashtag include. Um, to find it, it's the EYW in all caps, then .h, H is not in caps. And you use the carets on either side or whatever, like less than equal than things. That's going to go on the top, and that means it's going to start looking for some functions that we're going to use, custom functions for this project in the EYW library. Up top, we need to include also just preload in um, some variables. Speaker pin, sorry, speaker pin. We're going to make that equal to 5. And there's the LED pin, 3, and the button pin, 2, semicolon there. That'll help our cause. That's probably about it, it seems. Cool. You can always check your packet for any of this information. It's also on Blend. We need to initialize our rangefinder. And that's also pretty easy. We're going to type in EYW in all caps. It'll turn orange, just like this, and then 2 colons, and then rangefinder will also be in orange. We need to name our rangefinder. We could call it proximity. What they have done in the packet. It also has to end in a semicolon. I'm going to make one more variable here. It's going to be called distance, and it's going to be set to 0 initially. We just have to make it so we can reference it in the future. Inside the void setup, you're going to add some stuff. We need to turn on a new thing, and this is called the serial monitor. Serial spelled with an S, not a C. Serial monitor allows you to gather data from your Arduino and look at it on your computer. So this is how we're going to find out what values our proximity sensor, our rangefinder, is going to be coming up with. Serial.begin is how we start this. This is going to then be filled one argument, which is 9600, which is the speed in which this thing is going to be communicating with your Arduino. Cool. Now we can enter in get some data from our proximity sensor. Proximity.begin is how we're going to turn this on. No arguments there. Then we're going to have it chime at us. This is telling us that it's going to start finding our proximity here in just a second. Proximity.alarm. It needs a few arguments here. How many beeps? We're going to go 6 beeps at 659 hertz, which I don't remember what the note is. And we want it to do 50 milliseconds each. So it'll be really, 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 really fast. You can put a note here. Number of beeps, frequency, and then duration. Little comment there to help you out. Then you're going to calibrate this thing. Calibrate. It's We're gonna try 10 real quick. It's gonna be 10 readings, and it's gonna average them real quick to figure out how far away the ground is. This is now going to set whatever it reads as our ground value. So whenever it reaches this value in the future, it knows it has landed. If you check out, first of all, we can just check to make sure that this works. Everything here, click the check button. You should get good to go. It did not work. Forgot a semicolon here. Always forget one of those at least. Check that again. Um, you can now start using the values here, using the distance um, as you see fit in the loop. So, because you want it to do it over and over again, you can do distance now equal to um, proximity dot get distance. Now it's going to start reading sensor and turning it into distance, and you can print your distance values on the serial monitor, which is pretty cool. We do this thing called right here, serial.print, then print you a line with whatever you want on it. We'll do a string in this case to give us some information. Current distance equals. Then after that, serial dot print ln print line is going to hit essentially hit enter after each time this runs, so that each of these will be this will be on the same line on the serial monitor, and then we type in distance here, not in quotes because it's a variable, not a string. And now it's just going to print the distance over and over and over again. So you can check out what the distance is. To access the serial monitor, it's this right here. So once it's been sent to your Arduino and running, click on the serial monitor here. I don't have anything connected, so it's not going to do it. Um, it'll show you. It'll actually restart your Arduino and then start displaying this data right here. It's pretty cool. Check your packet for any additional functions that are useful to us and ask me questions when you have them. Cool.